All right, geometry lesson 6.3, we're going to prove triangles similar by using the angle-angle similarity postulate. Here, I have the postulate here for you to read. I know you've already written it in your book. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are considered similar. You can see here they've marked the two angles that are similar in both, so it's easy to tell which they're talking about. So when you're doing your homework, if they tell you two angles, if they show you that two triangles have similar angles, then you can write that similarity statement at the bottom that you see. Okay? So let's look at example 1. All right, at example 1, you have two triangles and you're to determine whether the triangles are similar. And if they are, you write a similarity statement and tell me why. Which usually when you say why, you just tell me the name of the postulate you're using to prove it. So let's look at these angles. We know that we have two angles that are definitely similar, right? They're both right angles when you're looking at them. So we need to decide if any of the other angles are congruent. We can say that angle D is congruent to angle G so far, but that's it so far. If I were to flip this little triangle around to make it sit the same way as this bigger one, you know that this is D, this is E, and this would be C, and my right angle were to be right here. And then they tell me this little angle, which is 26, right? Can we find the measurement of that missing angle up here? Do you remember all the angles in a triangle add up? Yeah. Do you know what they add up to?
180.
Yes, 180. So if I know this one's 90, I can say 90 plus, and I know this one's 26, and then plus, let's just call it X, it doesn't really matter. I can solve for that missing angle, right? Yeah. So 90 plus 26 would be
116, right?
Plus X equals 180, so then I subtract 116, and I get the other angle equals what? 180 minus 116 is 64. 64.
Yeah, 64.
Yep. So then I can look at that measurement and look at H and decide, well, 64 is what the big triangle was, so I can write the other statement that angle E is congruent to angle H. So now do I have two angles that are congruent to other two angles?
Yeah.
I actually have three, so yeah. So now I can write that similarity statement that we like that says triangle CDE is similar to triangle KGH. And then it says to explain, so you would just say by the A similarity postulate. Make sense?
Yeah.
All right, let's do the next example. Example 2. All right, so we have two parts to this one. We're going to show that the two triangles are similar. We're going to look at A to begin with. So we have triangle ABE and ACD. So let's make sure we know which ones these are. ABE is this little triangle, right? So sometimes it helps to redraw this and not look at them sitting on top of each other. ABE, and we know that this angle right here is 52. Woo. I don't know what I'm doing here. 52. That happens. I push a button and then I hit something else with my heel of my hand. All right, so then the other triangle we're looking at is ACD, which is the big triangle. So if I redraw that one, we have ACD. And I know this angle right here is also 52. Are there any other angles I know are similar to the other angle?
No.
Trying to trick you. Look at these two.
Oh, yeah.
Those are exactly the same angle, right? Because when it was sitting on top of each other, it's A. So then I know that those two are similar. So it says to show that the two triangles are similar. So you can say the measure of ABE and the measure of angle C both equal 52 degrees, because we know that, right? You could have also said just angle B and angle C equal 52 degrees. So that's the first thing we know. And then we know that angle A is congruent to angle A, right?
Yeah.
So because of those two things, we can actually say that these two triangles are similar. So ABE, triangle ABE is similar to triangle ACD. Make sense? Good. All right, let's go look at B. So we have triangle SVR, which is this little guy, and then we have UVT, which is the bigger one. We do know some information here because we see the two red triangle tick marks. What do those mean? When I have these two two triangle tick marks. That tells me that those two lines are parallel. Okay, that helps me with my angles because we learned about the alternate, exterior, interior, all that stuff. That's going to help you determine what angles are congruent here. So when you have two parallel lines cut by a transversal, which angles would be considered congruent? Do you remember? It's
Angles would be similar?
which angles would be similar because of those two parallel lines.
Or X.
We're going to say that this is your transversal, okay, to these two parallel lines. If I draw it out like that, do you remember which angles are similar? You'd have to go back and look probably. It's alternate interior, so on that side of it and then on this side. So you would say that angle S is congruent to angle U because of the alternate interior angle theorem. Phew, that's a mouthful. Okay, now are there any other angles that are congruent?
R and T.
I'll save you, there are two. Not necessarily, those are harder to prove, but we have this. I'm going to get rid of this because now we're just going to look at the two triangles.
RS and PT.
Nope, look right here in the middle. Do you remember what these are called when you have an angle right across from an angle? It forms that X.
It's
Starts with a V. Oh, hey, that's funny because it's a V point. It's the vertical angles theorem. Anytime you have an angle directly across from it where it forms that X shape, it's called a vertical angle, which means they are congruent. So you would say angle SVR is congruent to angle UVT. So now that we know those two things, we can say that triangle SVR is similar to triangle UVT by the AA similarity postulate. So a lot of your lesson is kind of poking around your triangles and trying to find which angles equal which angles. And have your journal handy because you're going to look at old lessons that have the alternate interior, exterior, all that stuff. So, any questions so far?
Yeah.
Okay. Let's do the practice at the bottom of page 376, just for a little extra, help. Let me take a picture. So let's look at this one. I have triangle FGH and RQS, and we're trying to decide if they are similar, and if they are, we write a similarity statement. So looking at this, do we know of a postulate right away that answers this?
No.
Okay, well, you have what kind of triangles here? When you have three angles, ooh, that's the highlighter. When you have three angles that equal each other, do you remember what kind of triangle that's called? It's okay. They are equal angular, which means they're all three of those. If you added all three of those up, you'd get 180, right?
Yeah.
So if I have three angles times whatever their angle is, that's going to give me 180. So if I divide this by 3, that would tell me what each angle measurement is. What's 180 divided by 3?
6.
So then each of those angles is going to equal 60 degrees, right? What about this other triangle? Do all three of those angles equal each other? So you're going to do the same process. So then each of those angles equals 60. So now does it show that two angles on one of them equal two angles on the other one? Right. So then you would say by the a similarity postulate, triangle GFH is similar to triangle RQS. So sometimes you gotta think outside the box.
It's gonna be hard.
You can do it. Assume that there's a way to do it until you've exhausted all the possibilities, and then go, okay, there must not be a way to do it. Because the majority of your homework, there's going to be a way to prove it. Every now and then you're going to have one that you can't prove. Do you want me to do one more?
Yeah.
Yep, that's what I was thinking. All right, so let's look at this number 2. So again, we have triangle CDF and DEF. So it's breaking them up into this, and I'm super visual, so I always redraw them separate. Okay, this is D, this is F, this is C, and I know it's 32. And then I know this one is a right angle. And then I'm going to draw my little triangle. And this is D, this is F, and this is E, and I know this one is 58. All right, so is there any other angles that we can just automatically assume on here? If this side is a right angle, what do you think about the other side?
So,
It's a right angle, right? Because if you add these two angles up on a line like that, they add to 180. So I now know that this for sure is a right angle. So now can I figure out what D is on both of these? Yeah. If D equals this 32, then we know we can have two angles that equal each other. So let's say 90 plus 58 plus missing angle equals 180. What's 90 plus 58? Plus x equals 180, subtract 148. And I get x equals, what's 180? That's 50.
52.
32, right? I don't know where I got 50. 32. So 32 is D over here. Is that the same angle as this missing one over here?
Yeah.
Yeah. So now we have two angles that for sure equal each other, so we can say triangle DCF similar to triangle, and this would be EDF. And it's again by the AA similarity postulate.
Does it matter how you put it? Like, you know how you...
As long as you do it in the same order. So on this first one, I put D, and then I went down the hypotenuse and put C. So here I put E, went down the hypotenuse, and put the next one.
What if I would have put DEF?
Not technically wrong. Is basically as long as your vertex, whichever point's in the middle, is the same point on the triangle, it works out just fine.
Okay.
So if you're unsure, I would actually go DFE and then just do it this way, DFC, because then F is in the middle of both of them and we know it's 90 degrees.
Okay.
It's not like uber important, but it's a good practice because in some instances later it is important.
So since since C is like in the tip, E has to be in the middle too. You know? Like,
Yeah, because look, these are the ones that have the two measurements. This is 32, this is 32. So you want whatever the measure is to be in the same. So in this case, the C was 32, and then the D was 32. So that's why I put them in the middle.
Okay.
Does that make sense? The other option is to take this little triangle and flip it so it's looking like the first one. So then this is your F, this is the D, and this is the E, and then it makes more sense because they are facing the same way.
Oh, yeah.
So when you redraw it, you could do that. Yeah. Ooh, this got colorful quick. Okay. I have confidence. You've got this. Ooh, time to go. So you're doing lesson 6.3, again, 3 through 35 odd.